In this video of chapter 9, we will study the response of the nerve fiber to stimulations of increasing intensities, and at the end of which the student will be able to define the threshold of stimulation and the threshold of depolarization of the nerve fiber, and to explain the response of the nerve fiber to stimulations of increasing intensities. First, at school, the needed average to succeed is 50%. If you get less than 50%, you fail, and to succeed, you should get at least 50%. So, 50% represents the minimum needed to succeed or the threshold of success. Do we have a similar case in nerve fibers concerning the response to stimulations? Let's see. In this experiment, we will stimulate this nerve fiber with an electric stimulation of increasing intensities, and using an oscilloscope, we will record the variation of membrane potential. The yellow line represents the stimulation, and the green line represents the membrane potential. And as you see, in the absence of any stimulation, the membrane potential is minus 70 millivolt, which means that the nerve fiber is at rest. Let's see the video, and after it, we will summarize the results. So in the video, if we consider that I represents the intensity of stimulation, for intensities less than 49 milliampere, no action potentials were triggered. At the intensity I 49 milliampere, the first action potential with amplitude 108 millivolt was triggered, and for all intensities that were greater than or equal to 49 milliampere, all triggered action potentials have the same amplitude. So I equal 49 milliampere is the minimum intensity that triggers only one action potential. So it is the threshold of stimulation, which means that for this nerve fiber to have an action potential, you should stimulate this nerve fiber at least by 49 milliampere. Okay, what do we have in this experiment? This is a nerve fiber. We stimulate it by S1 and S2, and we record the variation of membrane potential using two oscilloscopes, O1 having the recording electrode R1, which is near to the site of stimulation, and oscilloscope O2 having the recording electrode R2, and it is far from the site of stimulation. And these are the results. We stimulate the nerve fiber with 6 intensities of stimulations, okay, and we record the result. First, you know that if we stimulate the nerve fiber, this trigger triggers depolarizations, increasing of membrane potential. But sometimes no action potentials were triggered, and sometimes action potentials are triggered. What's the condition? There should be a minimum to be reached to trigger an action potential. What do we call this minimum? We call it the threshold of depolarization, and in our example, it is about minus 50 millivolt. So the definition of the threshold of depolarization is the minimum potential to be reached by stimulation to trigger an action potential. Now let's study the results. First, we stimulate with I1, I2, and I3. And as you see, they triggered an increase of membrane potential. But this increase remains less than the threshold of depolarization, so we can't have an action potential. Why? This is because I1, I2, and I3 are less than the threshold of stimulation of the nerve fiber. And as you see, this increase of membrane potential is recorded by R1, which is near to the site of stimulation, and is not recorded by R2, which is far from the site of stimulation. This means that this little increase of membrane potential is unable to move, unable to displace, and we call it local depolarization or hypopolarization. Now, if we stimulate the nerve fiber with I4, I5, or I6, we trigger action potentials of amplitude 100 millivolt. And as you see, this action potential can be recorded by R1 or R2. What does this mean? This means that only action potentials can propagate and not the little increase of membrane potential triggered by I1, I2, and I3. But why do we obtain action potentials with I4, I5, I6? This is because these intensities are greater than the threshold of stimulation of the nerve fiber. This is the law of all or none, which means that if we stimulate the nerve fibers with intensities less than the threshold, it doesn't trigger action potentials. If we stimulate it by intensities equal or more than the threshold, it triggers the same action potential with the same amplitude, and only the action potential can propagate, as we saw from these recordings. Now, what do we have in this experiment? S1, S2 are stimulating electrodes. O1, O2, and O3 are recording oscilloscopes. And as you see, the distances are given. All are about 1 centimeter. And we have also the time taken by the action potential to displace from a point to another. And we are asked to calculate the speed of the nerve impulse at each recording electrode, of course, starting from the site of stimulation. Let's see the answer. The same speed of conduction is obtained at each recording electrode. What does this mean? This means that in a nerve fiber, the action potential propagates at a constant speed.